Hello everyone, welcome to the lecture on cryptographic hashing, which is mostly used for preserving message integrity. Now, the first question is, what is actually hashing? So, hashing is nothing but a function or a algorithm which takes as input a message of arbitrary length, and it produces an output which is a fixed length. We compress the message into a fixed length output. So why do we use hashing? Now, number one, it is easy to compute. Number two is it is pre-image resistant, which means it is a one-way function where a hash on a particular x gives you y, but if you do an inverse function on y, it will not give you back x. For example, if we take the modulus operator in mathematics, where a mod b gives you the remainder of a divided by b. Say, for example, we do a modulus operator of 15 mod 4. It will give you the output of 3, right? Now, from 3, you will not be able to get back 15 by any means, because 7 mod 4 also gives you 3. But in case of other mathematical operator, for example, say we do like 12 divided by 4 gives you 3. Again, if you multiply 3 with 4, that gives you back 12. So there is an inverse function of division operator, that is multiplication. So if you know 4, if you know division has been applied, and if you have the result that is 3, you will be able to find out this x or 12. But in this case, you will be getting options like say 27, 7, 4, 15, so many options. If you know 4, if you know modulus operator has been used, and if you know this answer 2, but you will not be able to definitely find out this 15. Next, it is also second pre-image resistant, which means that hash of certain a if b m and hash of certain b is also m, it implies that a equals to b. Next, we have another property which is known as collision resistance, which states that hash of certain c is not equals to hash of d if c and d are not equal. Now, is it always collision resistant hashing? The answer would be no. It's very easy, because if we use, say, modulus operator for hashing, 15 modulus 4 gives you 3, and again 7 modulus 4 gives you 3. But in case of cryptographic hashing, we need to devise a way so that it becomes collision resistant. We need to incorporate the avalanche effect, which says that if we even do a minor change to the message, it will result in an entirely different hash output. We will see that in a while. Now, before seeing that, what are the applications of hashing? How do we apply hashing? Now, hashing, a very important application is securely storing the password. Where, say, there is a user, say Abhilasha, and Abhilasha signs up in a website, where the website uses a hash routine where the hash of the password is computed, and say that we HPWD, and that HPWD is stored in the in the database, the user database. Next time, when Abhilasha tries to log in to the same website, she'll be entering the password she used during the sign up phase or registering into the website, and the website will again do the same hash routine on the password entered, and say that be ppwd, and it will check ppwd against the hash that is stored in the website. Now, if both the hashes match, the login will be successful. Now, an important thing is that if the database is hacked by a malicious hacker or a user, what he or she will be getting is the hash of the password instead of the password. So he or she will not be able to log into the system using those hash, because whenever the user tries to log in using that hash, a hash of that hash will be computed, and that will be checked against the database, and definitely the hashes won't match, and the malicious user will not be able to enter into the system. Now another very important property is to preserve the data, to preserve the message or the data integrity. Now due to the avalanche effect, since if you make a small change to the original message, say if you add a punctuation or you just add a space, that will result in a very major a completely different hash output. So if a message has been tampered with in transit, it will be easily found out by computing the hash. Now, there are many hashing algorithms like Message Digest, Secure Hash Algorithm, RIPEMD, Whirlpool. So, among these, I will be giving you an overview of SHA256 algorithm, which is very important, and it is also used in security applications like blockchain. Now, SHA256 uses a hashing algorithm, which is known as the hashing function, which is known as the Merkle-Damgard construction, where a fixed any message is divided into fixed size message parts, and a construct compression function is applied to each of those parts in several iterations, and finally a collision resistant output hash is given. So in this SHA256 algorithm, a message less than 2 to the power 64 bits is used, that is the user message, and that is broken down into block of length 512 bits, where each word length is of 32 bits. Now SHA256 gives you the output of length 256 bits. Now if you enter a message which is less than 512 bits, it is padded and made up to 512 bits. Otherwise, the message is broken down into parts, and using necessary padding, like if it is necessary, the padding is used to break that down into, say, n parts of each 512 bits in blocks of 512 bits, and then an initial hash value is computed, that is computed like the first 8 prime number is used, where the square root of the first 8 prime numbers will be computed, and the first 32 bits after the decimal of this result will be taken as the initial hash value. So we get 8 initial hash values. Now next, in each round, so this is what happens, these are the registers, and the message, the different functions, the different compression functions are used. In this case we have this function which are used bitwise. Now this is done in 64 rounds, where in each round intermediate hash values are found, and after 64 rounds we get the final hash value, the output hash. And these different functions are bitwise functions, which are like CHEEFG is E and F XOR not E and G, and this one is actually A and B XOR A and C XOR B and C. I'm not going into the detail. These are constants which are changed in each round, so that one round differs from the other. So this is how the hash, the SHA256 is computed. Now are you curious to know that how it actually looks like, the output hash looks like? Let's see. Okay, so enough of theory. Now we'll look at how the digest of SHA256 looks like. So here I have used the command prompt to show you this. I'll be using hello world as my message, whose digest I will be showing you using openssl. I will be linking the link to this openssl software in my description box. If you are interested, you might go through it, install it in your system and see it yourself. So this is your digest for hello world. Now let's see how the avalanche effect works, if it at all works, or how good is that. So echo minus n. So what I will be doing here first, I will just be adding a space to this hello world after world. So the rest will be same, hello world. I just added a space, then I finish it off. And now let me compute, or let me look at how the digest of SHA256 looks like in this case. This is quite different, right? It was A213 and whatever ended with BF4, and this is quite different. Started with 3B and ended with 47, and the middle ones are also quite different. Now I'll play around a little bit more. This time I will not add anything. Rather, I will just be changing the H of hello world, the H to the lowercase. So the rest will be same. This was capital H. This is going to be the small h. So, and now let's see how the digest is computed here. Digest minus SHA256. This is quite different, right? It was A213 and this was a completely different digest that we get to see. So the avalanche effect does work because there was just one change. I just changed one case and nothing else. The entire message was same, but see, the digests are so very different from each other. So the avalanche effect work, and it works pretty nicely, and your digest is quite safe, we can say, right? So that was all for today. If you have liked my video, please give me a thumbs up, and if you like to know more about these, you can subscribe to my channel, and thank you for watching.